Good evening, meteorologist DT with the Snowstorm Podcast for Tuesday, February 20, 10:55 here in the East, and lots to talk about, so let's get right to it. Um, a very warm pattern here, no snow threats for the next 7 to 10 days, but there's some hint of something significant developing in early or mid-March, maybe. So definitely a change in the pattern. Whether it results in a snowstorm before the winter's out, that's an open question. But the potential is there. There are some things turning our way finally. Okay, that is our way if you like snowstorms. All right, not everybody does, which I can't figure out. Go figure. Anyway, let's look at the snowstorm matrix, and you can see everything right now for the next 7 to 10 days, February 29th. It's not a leap year. It's sorry about that, folks. So it's actually March 1st. My mistake. Anyway, you can see everything sucks. No storms every here, everything. Midwest, Ohio Valley, Deep South, Interior, Northeast, I-95. Awful. Okay. This is record temperatures for yesterday, February 19th, and you can see some very impressive extremes on both sides of the country. So, for example, see this little one here? That represents the hottest temperature on date for that location since records began. And if you see a 1 here, for example, that represents the coldest temperatures. So the 7 would represent here the seventh coldest temperature on record. So and so on and so forth. So now this was yesterday's, obviously, and of course we can see all the heat, the warm temperatures up in this way. Now the Midwest, the Mid-Atlantic, and the Northeast had not yet warmed up, but they were getting warmer, and you can see all this heat's going to spread to the east, and that's in fact what we saw this afternoon. Let me clear this out. So I'm going to advance it, and we can see the record temperatures here this afternoon on February 20th. There you go. And actually, this is probably incomplete. They need more warm temperatures than that, but that gives you a pretty good idea. Now, if this was the summer, this is the upper air pattern here as of Wednesday. Okay, so if this was summer, this is tomorrow afternoon, the 500 millibar map. If this was summer, July, August, and we saw this sort of pattern, there would be 100 to 110 degrees Fahrenheit temperatures easily over southern New England, the mid-Atlantic, the southeastern states, portions of the Ohio and Tennessee Valley. This would be pretty extreme heat. So it is unusual, to say the least. And to show you how extreme it is, yes, the warmest temperature on this date ever in February for Mountain Washington, which is usually the cold spot. Warmest temperature ever. So, and if we look at more record temperatures, this is this afternoon from the eastern region, National Weather Service, and you can see the extreme warmth in many areas, and you can just find your location here. It's just unbelievable. 77 degrees in Elkland, West Virginia. Can believe that. Holy mackerel. Huntington, 81. And tomorrow's going to be warmer, folks. Yeah, tomorrow's going to be warmer on the East Coast than this. So, it's pretty impressive. Philadelphia, 72. Pittsburgh, 78. LaGuardia, 64. Holy mackerel. Anyway, so that's pretty impressive stuff. And to show you how impressive this is the soundings. And you can see these different levels here. Now, typically, in the month of February, right here, you can see the 552 line is here, 540 line is here, the 5,600 decameters, or what we call 5,600 decameters is here, and so on and so forth. You can see that the ridge is extremely strong, almost at 6,000 meters. So this is almost at the top of the scale for 500. In other words, if this ridge was a little stronger, this would be a giant hole in the atmosphere because this level at 500 millibars couldn't see it. So this is off the scale, extreme record, and this is the sounding for, I guess that's for, New York City, OKX, so Brookhaven. Now, some of this I think is being caused by the change in the climate. So obviously this is going to cause a reaction by some of the extreme kooks out there, but not my problem. Now let me be clear what I'm talking about here. The change in the climate, which I believe is occurring for whatever reason, doesn't cause extreme weather. Absolutely correct that we have had extreme weather and climate patterns before, and they do occur naturally. 100% agree. But the issue is that when we do get extreme patterns, is the change in the climate causing them to be more severe, more intense? And the problem is, of course, is that this is very hard to prove. How do you prove that without having a time machine? You can't. But if the effect is true, then you have a problem. Just because I don't know what's causing the cancer doesn't mean the cancer isn't killing me. Same sort of thing here. Is the change in the climate causing the extreme patterns to become more extreme? How do you prove that? I don't know. but it is a real impact. It is a real effect, I think. All right, getting back to the actual weather here for the next 5 days, you can see the rains here over the Delta, the Midwest, on both these models, GFS, European, pretty significant. And some of these areas have been pretty dry, so this is much needed rain. All right, now here's the change in the pattern. Now this is the next 5 days. You can see the strong ridge here. This takes us out to February 25th. There you go. You can see right there. And here's our deep trough on the west coast. And here's our extremely strong ridge over the southeastern coast of Bahamas. And of course, the jet stream is doing this. So any cold front that comes through stalls in this direction. Over here is a polar vortex very far to the north. And again, it's shaped like a football. And whenever the polar vortex is shaped like a football, whether it's Dick Foles or Tom Brady throwing it, that's a bad sign. So that's one of the reasons why the pattern is very warm as well. All right, now, as we clear this out, this was the pattern here back on, when was this? Back on February 12th, last week. And 8 days ago. And this was getting a lot of people excited about this block developing, and I'm not very excited about it because here is the block developing over the United Kingdom and Iceland. So it's an eastern-based negative NEO, but we still have this very strong Pacific jet stream, and the trough is still on the west coast. So as a result, we had a southeast ridge. Now, the issue is, of course, is this going to retrograde and move to Greenland? Sometimes they do that. They don't do that all the times, but sometimes they do. This was the European showing the same sort of thing, and the ridge was much stronger. Notice that, again, this is valid for Thursday, the 22nd, and this is valid for the 26th. And you can see that in this image here, the southeast ridge is very strong, and then here, the southeast ridge begins to finally weaken as the retrograde moves towards Greenland. Now, this is the new stuff here. It came out early this morning, and you can see this is day 10. Now, both models show the block here, but they position a little differently. This is the European. You can see the block is in Greenland. All right, and the trough is still on the west coast. Much stronger block here, which pushes into Labrador, and it has a much bigger 50-50 low here. So this is a much more extreme looking map than the European. But both models still have a trough on the west coast, and that means you still have a ridge in the middle part of the country. So at this point on February 27th, we got nothing. Zero. Nothing's happening in terms of winter weather. This is still a ridge here, so anything coming up is going through the Great Lakes into New England in this direction. So this is no reason to get excited with the pattern yet. Now it just does show some potential, but in order for the pattern to change, these troughs on the west coast have got to move out to here. They have to. When they do that, the ridge will go to the west coast and we'll be in business. Question is, are they going to do that? Well, the changes started occurring. This was the European weekly model from last night. You can see here the trough, which was on the west coast, is now moving to the eastern Pacific. We're getting a little more, the ridge which here now begins to pull back. Here's our block, here's our negative NEO, and there's our big upper low over southeastern Canada. So this has some potential, but this trough still has to move. It's not quite there yet. Now the change occurred in the models this morning. You can see this is the GFS, the 6Z run from this morning. There's 240 hours out. There's our trough on the west coast. Here's our ridge over the Midwest still. So while we're getting some cold air getting into the country here, getting some cold air getting to the country here, this is still a problem. And you're not going to get any snowstorms on the East Coast with the ridge in the middle part of the country. That's simply not going to happen. Now this is the 12Z European that came out this afternoon, and there's our trough on the west coast, and here's our big ocean low off the southeast coast of Canada, and here's our block. So notice now the flow is, we no longer have a ridge here. We now have almost a zonal flow, and we're getting some cold air coming in this way. So yes, we are seeing some low pressure developing here, maybe some winter activity developing in the Midwest as the energy comes out of this trough on the west coast. So this has got some potential. Now this takes us to March 2nd. So maybe things might be turning around. And we can see this is what the 6Z GFS was showing in terms of the pattern potential. Now, again, we do not believe the 384-hour GFS. We do not believe the 366-hour GFS here. This is just giving an idea of how the blocking pattern might develop something. What happens is the low pressure area comes out of the west coast, and the block is here. So this thing stays to the south of Chicago, and then it develops on the Mid-Atlantic coast into a big storm, potentially with a big high pressure to the north. That's how the blocking pattern might develop conditions at the surface. Maybe, maybe, okay? Let's not get too excited about it just yet. Now this is the 19th. Oops, let me clear this out. And now this is the extended 360 hour from 0Z on Tuesday morning. And what happens here is that this is really important, really, really important. The trough is now here, folks. The trough is now moved off the west coast of North America into the eastern Pacific, and that pulls the ridge, which was here, pulls it backwards toward the Rockies. You see that in the west coast, and that means the trough is now deeper. So any low pressure area which comes out of the trough on the west coast, let's say here, now gets ejected southeastward, and then it gets to close off the Mid-Atlantic coast, and that's how you get your storm forming. That's why this ridge is really important. It allows the energy to dig down towards the Mid-Atlantic coast. Otherwise, you're just going to have, if that trough doesn't move to the eastern Pacific, you have this. And in which case, you have low pressure tracking like this, and it doesn't really develop. So that's why getting the trough to move from here to here is a big deal. Okay? All right, good. And then this is the updated version here. This is the 12Z GFS ensemble. And what's important to know is here is, again, the trough now is here. Excellent. We love that. And the depth of the trough on the East Coast is much deeper. 546 on the Virginia, North Carolina line. 540 line is by Pennsylvania, Maryland. And that is significantly deeper than the 0Z1 and the 6Z on the GFS. And we can also see that's also on the European. Same sort of thing. Excellent model agreement here. Really, really good. Yay. Now to show you the possible patterns, this came out from yesterday. This comes from Storm Vista. One of the things they do is they take a look at the 11 to 15 day, the top 10 analogs. And of course you can plot these up and see what the temperatures and precipitation are like. But one of the dates here of significance is March 1962, the Ash Wednesday storm on the East Coast. Now some of these other events were also significant, some of them were not, but this is one of the ones here. So this always draws attention. Now there are forecasters out there who every single March, anytime there's any sort of blocking pattern, this guy goes off his nut and starts screaming about March 1962. You know, if you keep saying it year after year after year, eventually you're going to be right. But you know, that's not really forecasting, that's just being stupid. So let's take a look at March 62. Now this was the night of March 5th into the 6th, and up here, this here's our upper air pattern, and there's our big upper low. See that on the eastern Pacific. Let me change markers here so we can see this a little better. Find a good color. Let's take a look at, yeah, I guess we can use the yellow here. That's good. So this was the trough here, and this is the upper low. You see that forming right there, right over Tennessee and North Carolina. Look at the huge block in the upper atmosphere right here. That's very much like the similar pattern we have. Now there's the low beginning to form. It's not a very strong low at this point, but you can see the temperatures are very cold at 850, and that's what produced all the huge snow in central and western Virginia and western North Carolina. In case you did not know this, you know, Richmond had 15 inches of snow, and the Shenandoah Valley had 20 to 40 inches of snow. Now the storm is obviously famous for the damage on the coast, so we'll see why, because here what happens is that on March 7th, 1962, we can see the low is right here, and you can see the very strong fetch of howling east winds. Oops. Look at these east winds coming into Virginia and Maryland and North Carolina and New Jersey. Very, very strong into even Long Island, New York. So that's what the problem is. Now the low itself is actually, upper low is now moving away from the coast. The low is fairly far out to sea. But again, it's pretty cold, and you can see the huge block here, the trough on the eastern Pacific, and the big storm off the coast. So a lot of similarities to this pattern, but that doesn't make it a certainty by any stretch of the imagination. And then this is March 8th. And again, even though the low is now way off the coast, look where this low is, folks. It's way the hell out. Look at this. It's way over here. But look at those east winds piling the water in here. And the other thing is we had a record strong moon tide as well, because the moon was at the closest approach to the that year to the Earth. So that was another factor as well. So, but to show you that there are other possibilities, again, if we look at this, remember this is March. Look at the first one, March 11th, 1958. So what does that pattern show? Well, here's our block, very strong, very nice there. The trough is here on the west coast, and as a result, because it's on the west coast, not out here, the low pressure travels in this direction and nothing develops. We have a weak little low you can see off the Carolina coast. It goes out to sea, doesn't do anything. It may have given some snow North Carolina, Southern Virginia, but that was about it. And this is March 22nd, 2006. And again, there are people out there talking about March 1962. Okay. But we can see a big upper low here like this, a huge blocking pattern here, but the low pressure areas travel like this. And because the trough is still on the west coast to some degree, and there's no amplification, and nothing actually happens. So, if we look at our teleconnections, we'll see that things looking pretty positive actually. Let's go here, and this is the we can. Is this the right one? Yeah, this is the EPO and the PNA, I believe. Yes, and we can see that the Eastern Pacific Oscillation does in fact drop way south. You know, it climbs up here, and then it goes neutral around the 25th or 26th, and it drops. And this is excellent. You want to see that. And of course here, this one here in the bottom, this is the PNA, which is very strongly negative. It begins to approach neutral here by March 6th. So that's an improving sign anyway. And then if we look at the Arctic Oscillation, we see it's strongly negative, and the NAO is strongly negative. So these are all excellent signs for the East Coast snowstorm potential down the road. Maybe. So again, if we look at the MJO here, oops, clear this out, MJO, we'll see that right now it's in phase 7. It says 6. It should be in phase 7. So let me change that so you can see it. I'll change the color here again. This is now actually phase 7. And you can see. Now the issue is, does it go into the neutral circle or does it come back out to phase 8 and phase 1? That's the question. Now right now, most of the models are taking it, keeping it alive and taking it into phase 8. So this here is the CFS ensemble, and you can see into March 5th, it takes it nicely into phase 8 and phase 1 as we approach the East Coast storm potential, March 5, March 6, March 7, March 8. This here is the Japanese model, which takes it out to February 28th into phase 8 and phase 1, and then a little bit into phase 2. And then this is the European model, and you can see the European keeps it into phase 8 weekly, but stays in the phase 8, and then turns it into the neutral circle by the middle of March. So that has some potential, and the reason why we talk about that is because that's what it looks like in La Nina with phase 8. It does indicate a storm potential here on the East Coast, and this is phase 1, which also favors a storm potential on the East Coast. So in summary, what we're talking about here is the potential for an East Coast winter storm of some significance around the March 5, 6, or 7. But in order before us to go really excited, we're going to have to make certain that trough on the West Coast moves out into the Eastern Pacific. Otherwise, it's going to be another close miss with not much happening. And given how this winter has developed, it's okay to be skeptical. Now, if we're still seeing the trough on the West Coast move to the East Coast, on the West Coast move into the Eastern Pacific by, let's say, Saturday or Sunday, then we're in a ball game. But we have to wait for the rest of the week and see how it plays out. This is meteorologist DT from weatherist.com. I'll see you on the Facebook page and on the Twitter page.